Hey, today's video is going to look a lot different because there's not a whole lot to write. In fact, I started trying to write it and I just need Desmos. And so this is going to be a lot of me talking, so I apologize. It says, in this lesson, you'll investigate the characteristics of the family of functions y equals b to the x. As a team, you'll generate data for various functions in this family, form questions about your data, and answer each of these questions using multiple representations. Your team will show what you've learned on a standalone poster. We're not going to do the poster. So in chapter 5, so what we just did in the last week or so, we graphed several exponential functions. Some, like the one that modeled the rabbit population in 5.4, were increasing exponential functions, and they look similar to the two that are right here. And then when we did the rebound height graphs from the bouncing ball activity, it was like this. And so it was decreasing exponential functions that look similar to the third curve shown in bold. So it was decreasing as we went. You already know that equations in the form y equals mx plus b represent the family of lines, and you know what effect changing the parameters m and b have on the graph. But today we're going to start looking at the exponential function family. In their simplest form of the equation of exponential functions look like y equals b to the x. So by experimenting with different values of b, we're going to find three equations in y equals b to the x form that you can have graphs appearing to match the three graphs shown above. Confirm your results using your graphing calculator and be ready to share your results as a class. So we basically are just going to go to Desmos here and see what happens with different values. So if we have y equals 3, to the x, and I just used shift 6 to do that without the calculator, this is what it looks like. What if I say y equals -3 to the x? What that looks like. What if I say y equals 1/2, now I have to click off that, to the x? Let's see what happened with that one. And then let's do some of our boring numbers here. What if we do y equals 1 to the x? Or what about even y equals 0 to the x? There you go. So you can see different equations here and what happens to them. I'll click off and on so you can see them. Please go to Desmos yourself and play with these so you can see what is happening. Okay, so then I'm going to click off that and we're going to go to page 2. You know me, and zooming in on these, it may make you dizzy, so hey, I didn't do too bad. Okay, can't see the very top, but I have it right in front of me, so I'm going to read it. We're going to investigate y equals b to the x. So what type of graphs exist for equations that are in forms y equals b to the x? Those are exponential equations. That's what we started in chapter 5, and all of chapter 7 is going to be exponential equations. It says, with your team, try different values of b to try to find different looking graphs as possible. Stick to small values, numbers that are less than 10. Keep the window on your calculator set from -10 to 10 as x and y decreases. Or, wow, sorry, in both the x and y directions. That's embarrassing. So I've already put several in here. Let me show you how you can change your window setting. If you go up here to the little setting thing, the x value is set from -10 to +10. And let me move me out of the way here. And then the y value, you can also set it from -10 to +10. So that's one way you can do it. You can also zoom in, out, and that adjusts your window on Desmos as well. But all of that, again, is in this. So I want you to, again, play with Desmos, kind of do what I'm doing here, so you can get comfortable with it and change your window size. So it says, decide as a team what different values of b to try, so you find many different looking graphs as possible. So this is kind of boring because since I'm doing it relatively for you, it's the ones that I tried, you'll see that I have a positive number, I have a negative number, I have a number that's less than 1, but not negative. And then I tried our boring numbers. So, and you can tell by the graphs, those are boring graphs. So those are straight lines. So the three really that I like to try are positive numbers, negative numbers, and fractions. So then down here at the bottom, it says the graph of the function 1/2 to the x is shown to the right. Describe what happens as to y as x would get bigger and bigger. So if we are looking at this graph, using your imagination here, if x is like 20 or 100 or 1,000, you're going to notice that this is going to go really, really close to 0, but it's never going to cross the x-axis. So it's like you can't even tell, but if I start zooming in, I mean, I'm gonna have to zoom really far in for this not to look like it's at 0. Wait, did it start zooming out again? Maybe it only went so far, but it will never, ever, ever reach 0, and it'll never intersect, like it'll never cross. And so that's going to be called an asymptote, which I imagine it's getting ready to tell us that. So does it have an x-intercept? No, like it will never cross 0. When x is very large, the graph of y equals 1/2 to the x approaches the x-axis. That is, as x gets larger and larger, further to the right, the closer the curve gets to the x-axis. In this situation, it's going to be called an asymptote. Again, an asymptote means that it's going to get really, really close, but you could like zoom in so big that you'd see that it's not quite there, and it will never intersect. We will read more about asymptotes throughout this lesson, or throughout this chapter. Does y equals 1/2 to the x have a vertical asymptote? In other words, is there a vertical line that the graph above approaches? And so if we go back here, to zoom way out here, does this ever approach a line and never go over it? And the answer is no. I don't think so. Like, I think it looks like that, but I think it'll just keep increasing because you can always pick different values of x without it intersecting. So I think the answer to that is no. If that's different, I will correct it and write it on my It's Learning page. So then on to page 3. See what I mean? It's just a lot of talking and playing with Desmos. So now that you and your class, aka your teacher, have found all the possible graphs of y equals b to the x, I'm going to assign you a couple to explore further, which I'm not going to do that. And so I just really want you to go through and I want you to play with Desmos like we did. And so what I want you to do down here, it says exponential functions have some interesting characteristics. Consider functions of the value y equals b to the x as you discuss the equations below. Exponential functions, such as y equals b to the x, are defined only for where b is greater than 0. Why do you think that is? That is, why would you not want to use a negative value of b? Well, when we did that, actually, you know what? I bet if I were to put that in parentheses, it would not even show up. Yep. So with this in parentheses, why did nothing show up? So I want you to think about that, and you're going to have a question on a Peer Deck slide for that. And then also, can you consider y equals 1 to the x, or even 0 to the x as an exponential function? Why or why not? And how are they different from the other exponential functions? So again, you decide, and then you'll write on a Peer Deck. Can you consider this one an exponential function? Or what about that one? So look at those two things and think about those, and you will answer the questions on the next couple Peer Deck slides. Thanks.